So I would like to make a little summary of a very important concept of calculations in chemistry, is the mole ratio. Okay, because having the mole ratio can help us identify the amount of substance of other compounds in a chemical reaction or other elements, depending on the chemical reaction. So what it is a conversion factor between the number of moles of a compound in a balanced equation. And this is used to predict the amount of substances. It's derived by the coefficient in a chemical equation or the number in a formula. So in a chemical equation, let's take an example of this equation. Chlorine reacting with 2KBr to give Br2 and 2KCl. So this equation needs a balance because, of course, we always need to have the same number of elements or atoms on both sides of the equations. That's why we put the coefficients here at the front of the compound. Now remember that this means that one chlorine reacts with the 2 KBr in order to form the products. So this is a conversion factor. What this means is that for every one chlorine, we have 2 KBr. So if we're given the mass and we can find, and we find that we have 0.5 moles of KBr, we can find how many we have of the chlorine. And it's a conversion factor, so we need to think, how do we turn these 2 into 1? Well, we divide it by 2. So the same change will apply for the actual number of moles that we have. So this would be 0.25. So this is applicable for chemical equations. So in this case, the ratio is given by the coefficient, but actually also for the numbers that we have in a formula of an atom. So, for example, in H2SO4, for each compound of sulfuric acid, we have 2 hydrogens. So this conversion would work to find the number of moles of hydrogen in that compound. If we have a 0.25, we double it. And in this case, as you can see, it's really simple because we see the difference. So this would be 0.5 as well. Why the ratio is so important? Well, it's important because knowing the ratio, we can find the moles of the other elements in the compound, and therefore we can find the mass, the volume, the concentration, whatever is that we're finding in that calculation. So I really want you to get used to these things. Moles, ratio, moles. It's everything in those like all these calculations where we have comparison of amount of substances. We will use this. Moles, ratio, moles. Really, it's important to just get it in your mind because it will help us start in pretty much every calculation in chemistry. Let's do some examples. Okay. So let's look at this equation that has, as you can see, balancing numbers in front of each component. Let's say that we have 0.5 moles of aluminum oxide, and we want to find how many moles of aluminum and oxygen will be formed. I would suggest you to get used to set it up in a little table. Okay, then the more practice you do, you won't need a table. You will be able to calculate the rate, like the moles in one step. But when you started this calculation, or if you just want to be tidy, or if for example an exam and you're a bit anxious, just do all the steps. It's really important not to miss any step. So we are comparing those two. Yeah, and aluminum. Actually, we could include also oxygen, why not, in the table, and oxygen. Remember that the balancing numbers, those big at the front, is the ratio. So let's do it. Let's set up this little table like this. Ratio, we would have 2 of aluminum oxide. What it tells us is that for every 2 aluminum oxide, we get 4 aluminum and 3 oxygens, and this can be moles, this can be particles. It's a ratio, so it's just a conversion factor, as we were saying before. Okay, and now what do we have? Well, we have a 0.5 moles of aluminum oxide, and here is the moles. So how do we get the moles of the rest? Well, we applied that same change.
Times it by 2, so it would be 1.
Exactly, would be just times it by 2, applying the same change. Exactly, it's just 1 mole. And then what about from 2? So from 2 to 3, we need to think about how do we convert 2 into 3. And the easiest way is to use the reverse fraction. So if we times this 2 by 3 divided by 2, we're turning 2 into 3. Think about as a calculation, 2 times 3 over 2. What do we get? We get the 3. And of course, we can also use it with a calculator, because 2 to 3, we know that it's times it by 1.5. But I think using the reverse fraction, it really helps with a bit more complex ratios. So the same change will apply, which means that the moles of oxygen would be 0.5. Let's do it in the same color as here, would be 0.5 times by 3 divided by 2. That would be our moles. So when we have an exercise that we want to apply this concept of ratio to an actual exercise, we need to think about, well, it's always, sometimes it feels a bit difficult to start because we have many words, we have equations, we have numbers. That's why I say try to get in your mind this: moles, ratio, moles. Because we know that the first thing that we will have to do is find the moles. How do we do that? Well, we need to think about what quantity are we given. This is a mass. So that would help us by analyzing the number, the unit, the wording. We can understand what quantity we have, and therefore we can write down the equation that we need, which is mass moles mR. Okay, so the first step will always be finding the moles. So one way to make it a bit easier to interpret, we can put a little tick on what we have the mass of, and we would understand it by just reading the question, because here we see the number and then of something. So of that will be the mass that we have. So it's really important to just read it carefully and slower. So in this case, it's 640 grams of iron oxide. So we know that that's what we have, and therefore that's what we can find the moles of. And to understand what we're asked to calculate, we needed to really analyze the question and look what's right after the question, the question, like what mass of, and that would be whatever we need to find. Okay, so we could also highlight, for example, or aluminum and then iron oxide are the two things that are involved. You could highlight the number, okay, but it's just important not to overdo with highlighters because it could be confusing. That's why I think it's useful to translate that into the equation. You could also write, okay, what do I have? I have 640 grams of this, and this is what I need to find. That could be another way to make it really nice and clear. Okay, now we have this. The first step would be to find the moles. One of the most important thing about doing a calculation is slow it down and be tidy, because it's easy to just rush, put everything in the calculator, and then, oh, wait, what did I just do? Confusing. So step by step, it's really important to do it slower. Yeah, for example, what I mean is we're finding the moles. We're finding the moles of what? Iron oxide. Great. Let's write that down even before we consider the number. Okay.
The number is 55.
Okay, so we could do that, but slower. That's what I say, slower always. We can do, okay, we have the mass, 640 grams. We know according to the equation that we wrote on the side, we need to divide it by the MR. Great. Maybe we can find the MR. We could write it here on the side, or you could write it when you do the other calculation. You could do it all in one in the calculation of the moles, whatever it's easier. But I do like to write things around the equation because it makes it always a bit more visual. So first, let's find the MR of iron oxide by consulting the periodic table.
All right.
So now that we found the MR, looking at the periodic table, we can find the moles of iron. So we would do 640 grams divided by 160,
which is
exactly, which gives us
4.
Good, nice round numbers. It's 4 moles, perfect. Very important, write the units down and the labels. First step done, ratio. Yeah, and it's really important to do the ratio, to get used to do the little table that I explained before. So let's set it up. What are we comparing? We're comparing iron oxide because that's the amount that we're given, and then what mass of aluminium. So that's the other thing we're comparing. Okay. So the ratio is given by the number, the balancing number. So as you can see from the equation, we have 1 iron oxide because we don't have any balancing number, and 2 aluminium. So this is our ratio and the first thing that we write in this table. Then we can find the moles of that. So the moles we've just calculated were 4 moles of iron oxide. Then we always need to think, okay, we need to apply the same change. So going from 1 to 2, we times it by 2. So the same change will apply to that 4. So we will have 8 moles of aluminium. Okay. So ratio done in the table, moles done also from the table. So now we need to go back to the question and think, okay, so what do we actually need to find? What mass of aluminium? Great. Let's write that. That's what we need to find, the mass of aluminium, and we can go ahead with the calculation. We could rearrange the equation, or it's important to have it always there visual so that we can rearrange it easier. So the mass of aluminium is equal to the moles of it, 8 times the MR. We can consult the periodic table, or you can do this all before. You can write the MR before you start the calculations. Find your way. And the MR of aluminium, we can write it here, it's 27. So we would write here 8 times 27, and we will get our final mass. So big number, 216 grams. Yeah, very important to write all these labels. Yeah, build the habits of doing all of these steps slowly and carefully. Yeah, and I think like this, no exercise can be too difficult. Okay, these steps really help to get start every exercise. Okay, I hope this helps.